This is part 2 of circuit design. In the last video, we completed the analysis of this circuit. Before we begin into the details, I would like to analyze one or two more circuits so you really have a firm understanding of the structure of a circuit. Let's look at this circuit. Once again, you can see that there is a top rail and there is a bottom rail. Bottom rail usually is the negative, and the top rail is usually the positive. What normally happens is there's a power supply that's used and connected up here and down here. But on circuit diagrams, they rarely draw the power supply. We happen to know that this top rail happens to be the plus, and the bottom rail line happens to be the bottom or the minus. Also note that the vertical lines lead up to the power rail, and they also may lead down to the negative. That's usually a standard in schematic drawings or circuit diagram drawings. And also, you might see again that signals are usually drawn as horizontal lines. And you may have additional components specified by the design to help the component operate correctly. For example, this piezo here is probably an additional component that's necessary for this M66T block. This voltage divider may be necessary to divide the voltage between a higher voltage and a lower voltage. And this capacitor may be used to help stabilize the voltage along this line. So once again, you must follow the basic rules for circuits. This could be considered a block, and this could be considered a block, and perhaps this might be considered a block, and maybe this might be considered a block. And here is another block. So when you first designed the project, this project perhaps had one input and 3 outputs. But when you look at the circuit diagram, there are additional components that may be necessary to complete the design. Here are other circuits that you can see the format. Rail, signals going in, signals coming out, output component, input component, and additional components that are needed to help the components work. I like showing these examples because it shows you clearly the structure of the circuit diagram. Input component, another input component, and additional components that are used. Output components and output components. So you can see that this looks almost like a block diagram, but a lot more detailed. Now let's get started. Originally, we said we would start with a block diagram. And now we have to change this into a circuit. Well, first, we would normally start by, like before, drawing some power rails. I usually start by drawing the controller in the middle. And I know my controller is going to need power. If you look at the basic STAMP microcontroller, you will see that it does have connections here for power, for positive and for negative. Positive is VDD and VSS are your negative. So in actuality, for the basic STAMP, I have two lines going. But I don't have to join it like this. I could just connect it here. Another option could be I just draw it as a ground symbol and make sure this is a ground symbol. And I could also not draw it like this. I could simply draw a dot and just call that VDD. And once again, I know that means it's connected to here, which is VDD, and this here, which is ground, or we can call it VSS. There are many designations. You might also see VCC, and you might see VEE. Just for your information, the reason why they use C and E is because most electronic circuits generally has a collector and an emitter transistor. For BJT transistors and for FAT, they may have a drain and a source. So this is consistent with the type of electronics or technology that is being used within the component. And you might even see V plus and V minus. Your experience will help you guide you through these options. So for now, to keep things consistent, I will stick with what we saw before and draw the lines. Now going back, I have a component in my system called a temperature sensor. Now, temperature sensor comes in many forms, but the temperature sensor that I'm using looks something like this. It has a box and it has 3 pins. Now, in order for me to know how to join these 3 pins, I have to go look at the data sheet. I happen to know that one of the pins will go to the positive rail and another will go to the negative rail, and there's something called an output pin. Why? Because I know from the data sheet that this will, based on temperature, output some type of voltage. So I know that this will be my green color, and this will be my red color, and this will be my black color. You can only get that from the data sheet by reading the specifications. I mentioned before that the temperature sensor cannot connect directly to one of the inputs of the microcontroller. There must be something in between. I happen to remember that I am using an analog to digital converter, And I read the data sheet and learned that one of the pins is called VN plus. And then there's another one called VN minus, and that will connect to the ground. And I also know that this analog to digital converter also has a power pin. So this analog to digital converter has this. Now, as far as the output, the part that is used by the mic controller, I remember that this analog to digital converter had 3 pins that will be used by the mic controller. So the mic controller has 16 pins, P0 through P15. These pins are available as inputs or outputs to the mic controller. So I decided to use the first 3 pins, P0, P1, and P2. And this will be used to operate the analog to digital converter and read the values. Sometimes I am very clear about what direction information will travel in my system. And I know that here there will be information going here and information going here. And these two will actually be coming from the mic controller to make the request from the analog digital converter. And I also know that the output that comes from the analog digital converter will be in a signal form like this. This is the information I expect you to know and get from the data sheet. All right, that's the end of part 2. I have concluded by showing you how to build up your circuits by taking the component and deciding which part of the component connects to the power and which part connects to the negative and what part of the component is the signal. You get this information from the data sheet. Thank you. Next, I will continue in part 3.